Hello, myself Shubham Singh. I am from NIT Andhra Pradesh. Today I am going to teach Bohr's atomic model of an atom, postulates and the derivations of radius equation and energy equation. Before coming on the Bohr's atomic model, first we have to know that why Bohr's atomic model has came. Actually, there have some drawbacks in Rutherford model. What is the major drawbacks in Rutherford model? Actually, there have two major drawbacks in Rutherford model. First one is Rutherford fails to explain the stability of atom, and second is Rutherford is fails to explain the line spectrum or discrete spectrum. To overcome both these two drawbacks, the Bohr's atomic model has came. Then we will discuss postulates of Bohr's atomic model. Postulates of Bohr's atomic model. First postulate of Bohr atomic model is electron is revolving only fixed closed circular path, that is orbit, and in other words it is known as shell, with fixed velocity and fixed energy. Electron is revolving only fixed closed circular path, that is orbit or shell, with fixed velocity and fixed energy. The second postulate of Bohr's atomic model is quantization condition. Quantization condition means if it is a nucleus and it is an electron, and this is the orbit of that electron, the quantization condition said that electron is revolving only those orbitals whose angular momentum is integral multiple of h upon 2 pi. Means electron is not revolving anywhere of the nucleus or anywhere of the space. Electron is revolving only those orbits for which angular momentum is integral multiple of h upon 2 pi. Means if we will note angular momentum L, then L will be n into h upon 2 pi. What is n? N is the orbit or shell, and h is the Planck constant. And what is L? L is the angular momentum. We know that L is equals to P cross R vector. What is P? P is the momentum. We know that P is equals to mv. If electron has m mass and v velocity and the radius between nucleus and electron is r, then P is equals to m v vector cross r vector. We know that A cross B vector equals to AB sin theta. So that mv r into sine. What is theta? Theta is angle between v vector and r vector. This is the r vector and this is the v vector. So theta will be 90 degree. So mvr sine 90. Sine 90 value is 1. So L is equals to mvr. So mvr is equals to n into h upon 2 pi. This formula we will note as in corner because we will use at the derivation of radius equation. mvr equals to n into h upon 2 pi. This is the second postulate of Bohr's atomic model. What is the third postulate of Bohr atomic model? While electron revolving, the electrostatic force between electron and nucleus provides centripetal force. Centripetal force means if this is the nucleus and this is the electron which are revolving around the nucleus, it will moves around the nucleus only and only when the centrifugal force which is coming in this direction and the centripetal force which is coming in this direction, then it is denoted as Fc, and another force will be also there, that is electrostatic force. It will comes by or due to the nucleus charge and the electron charge. The electron charge is E and the nucleus charge will be, actually in nucleus there will be proton plus neutron, but in neutron there have no charge, so we will not consider neutron because it will not help to consider the electrostatic force. So let's assume there have n number of protons in nucleus, so the total number of charge inside the nucleus JE. The charge of proton is positive, so the total charge of proton and the total charge of the nucleus is plus JE. So if it is E electron and here charge is plus E, so it is the Fe. Fe will be here due to electron and nucleus charge. So we will see that Fe is equals to Fc. Fe is equals to Fc. We know that centripetal force is equals to, means Fc is equals to mv square by r, and Fe electrostatic force is 1 upon 4 pi epsilon naught q1 q2 upon r square. Q1 is the electron charge and q2 is the nucleus charge. So 1 upon 4 pi epsilon naught E into ZE divided by R square. So from there we will get 1 upon 4 pi epsilon naught JE square divided by R square. We will put both values in equation 1. So we will found that mv square divided by R is equals to 1 upon 4 pi epsilon naught JE square divided by R square. This is the third postulate of Bohr's atomic model. We will note this point as there because it will also use in at the time of derivations of radius equation. mv square divided by R equals to 1 upon 4 pi epsilon naught JE square divided by R square. The fourth postulate of Bohr's atomic model is while electron is revolving in a fixed orbit, then it, it will neither gain nor losses energy. Means if electron is revolving in a fixed orbital, at that time it will not gaining or loses energy. And the final postulate of Bohr's atomic model is while electron is changes their orbit at that time it will gain or loses some energy. Means if this is the nucleus and this is the first orbit, this is the second orbit, if any electron which is moving from first orbit to second orbit, we have to actually this orbit has more, actually this orbit has I think minus 13.6 electron volt energy. Actually where it will, from where it will come, if I will tell you it will come from energy equation. I will derive after then you understand. And after 13.6 divided by 4, then it will come minus 3.4 electron volt. Means here and here we compare the energy, then here is the less energy and here is the more, sorry, here is the more energy and here is the less energy. Means if it will go here, then the energy level will be increases energy levels. Means we have to give some energy for electron moving from first orbit to second orbit. Means E1 plus we have to give like delta E energy, then it will reach in E2 orbital or E2 energy level. Then from here we note that E2 minus E1, delta E is equals to E2 minus E1. It is the final postulates of Bohr's atomic model. From here we will go next to derivation of radius equation and energy equation. For radius equation we will use both equations. We will do square of this, and then we got m square v square r square equals to n square h square upon 4 pi. And let's assume this is the first and this is the second equation and this is the third equation. Then we will do divide from third to second. M square v square r square divided by m v square divided by r is equals to n square h square upon 4 pi divided by 1 upon 4 pi epsilon naught z e square divided by r square. M to m cancel, v square to v square cancel, 4 pi sorry, here will be 4 pi square because we have done square of that first equation, so 1 pi will be remaining and 1 pi will be cut out. 4 will be cancelled, so here we will got m into r square into this r will be goes up and n square h square and epsilon naught and r square will goes up divided by this pi has remaining, so pi into z into this r square e square, so r square to r square cancel out, m we will send here in denominator, so rn for rn is a nth orbital radius is n square h square epsilon naught upon m into pi into z into e square. Actually in this equation, let's assume this is the third equation and we will note this on there because it will use in the energy derivation of energy equation. So Rn is equals to n square h square epsilon naught divided by m pi z e square. Here n is the variable because n is the cell number can be 1 2 3 and z is the atomic number of h atoms or h like atoms, and h is the Planck constant which is constant, and m is the mass of electron, pi is constant, and this is the charge of electron. So after putting the constant value in this equation we will got Rn equals to 0.53 into n square which is variable upon z. It is comes in angstrom. This is the final radius equation of an atom. And next we will move for derivations of velocity equation. What is the we will use equation first, mvr is equals to n into h upon 2 pi. We will put the value of r for in the equation of 1. So m into v into r is n square h square epsilon naught upon m into pi into z into e square is equals to n into h upon 2 pi. 1n to 1n cancel, 1h to 1h cancel, pi to pi cancel, m to m cancel. So Vn, velocity of nth orbital for the electron, V equals to, we will put in, or we will send it to denominator and we will send it to nominator. So z into e square divided by z into e square divided by 2 into n into h into epsilon naught. This is the velocity equation. We will note this to there because it will also use in the derivation of energy equation. So Vn is equals to z e square upon 2 into n h epsilon. So h epsilon naught into n. Here z is variable and n is variable. So uh, write in right manner, e square z upon 2h epsilon naught, it is the constant upon n. This value is 2.18 into 10 to the power 6 into z upon n meter per second. This is the final velocity of an electron in nth orbit. And next we will move on the derivation of energy. The derivation of energy, let's assume it's a nucleus and electron is moving around the nucleus. Then actually it is revolving so that it has some kinetic energy, and due to nucleus and electron charges there have some electrostatic potential energy. So first we will found the kinetic energy of electron for nth orbit. So k is equals to half mv square. We will put velocity of nth orbit uh, of an electron in this equation and got ke means kinetic energy half into m into n square h square epsilon naught upon m pi z e square का square. From there we will got m to m 1 upon 2 into m into n to the power 4. Sorry. Actually, I put this. This is the radius. That's why we will put here the velocity. Z into e square divided by 2h epsilon naught into n. So from here it will z square e to the power 4 divided by 4 into h into epsilon naught square. We will write in a good manner. Then 1 upon 8 into m is constant, e to the power 4 is constant, divided by h is constant, epsilon naught is constant, and z square is variable and n square is also variable. After putting the value of these constant terms, then we will got 13.6 into z square upon n square electron volt. So Ke will be this one.